Okay, so we are going to fill in this blank unit circle, and I'm going to start here at 0. So the unit circle has a radius of 1, which means that this point over here is 1, 0. And then up here, you're one away. The distance from here to here is 1, so that's 0, 1. And then over here is -1, 0. And then down here is 0, -1. So those are the 4 quadrant points along the unit circle on the coordinate plane. We're going to start by filling in the angle measurements. So over here in quadrant 1, this first angle is going to be 30 degrees. 30 degrees corresponds with the radian point pi over 6 radians. So this angle here is 30 degrees. The arc length along the unit circle is pi over 6 radians. And then the next one is 45 degrees, which corresponds with pi over 4. And then 60 degrees corresponds with pi over 3. And then up here is a 90-degree angle, and that corresponds with pi over 2 radians. Okay, I'm just going to continue around the unit circle and fill in the angles represented. So this first angle in quadrant 2, this angle here is a 120-degree angle, and that works out to be 2 pi over 3. And then there's 135 degrees is 3 pi over 4 radians. You can do the calculations if you want. That's the 40, it's the pi over 4 angle in quadrant 2. So if I were to measure this angle, that would be 45 degrees. That's the 45-degree angle in quadrant 2. I'm just going to erase that so it doesn't get more confusing. And then 150 degrees is the next one. Again, I measure that. That's 180 minus 30 degrees. So this is a 30-degree angle here. This is a 30-degree angle here. That's 180. 180 minus 30 is 150 degrees. Okay, and 150 degrees, just so you know where I'm getting this, 150 times pi over 180 simplifies down to 5 pi over 6. So this angle is 5 pi over 6. And of course our straight angle is 180 degrees. That's pi radians, halfway around pi radians. Okay, so from 180, if I add 30 degrees to that, I'm at 210 degrees. If I add pi over 6 to pi, I'm at 7 pi over 6 radians. And then if I take 180 and add 45, I'm at 225. If I take pi and add pi over 4, I'm at 5 pi over 4. If I take 180 and add 60, I'm at 240. If I take pi and add pi over 3, I'm at 4 pi over 3 radians. And 3/4 of the way around is 270 degrees. That corresponds with 3 pi over 2 radians. Okay, so So that's quadrant 3. Up here is quadrant 2. And then quadrant 4, if we start at 2 pi, so this is 0 or 2 pi radians, same as 360 degrees. So we've gone all the way around now. If I subtract 30 degrees from that, if I subtract 30 degrees, oh wait, that looks a little confusing. This is 0 and 0. This is 360 and 2 pi, but they're the same line. They correspond with the same point, and that's the point 1, 0. So if I take 360 and subtract 30, I'm at 330 degrees. And if I take 2 pi and subtract pi over 6, because this angle here, this distance is pi over 6, well, this distance here is also pi over 6. It's negative pi over 6. So 2 pi minus pi over 6 gives me 11 pi over 6. And then 360 minus 45 gives me 315. And 2 pi minus pi over 4 gives me 7 pi over 4. And then 360 minus 60 is 300 degrees. And 2 pi minus pi over 3 gives me 5 pi over 3. Okay, so those are all of our angles in both degrees and radians around the unit circle. And now to fill in the x and y values, so each of these points along the unit circle have a corresponding x and y value. The x, recall, the x is equal to the cosine of theta, and y is equal to the sine of theta. So you can find the sine of 30 degrees is 1/2. The cosine is radical 3 over 2. The cosine of 45 degrees is radical 2 over 2. And the sine of 45 degrees is also radical 2 over 2. And then for 60 degrees, the cosine now is 1/2. And the sine is radical 3 over 2. To find the values in quadrants 2, 3, and 4, the only thing that's going to change from these values from quadrant 1 will be the sign. Okay, so